Our third video for projectile motion involves a tennis ball being thrown downwards at a velocity of 8 meters per second. And we have two questions we need to answer. The first is, what's the impact velocity of the ball as it hits the ground? And the second one is, how long does it take? What time does it take for this ball to travel 7 meters and strike the ground with an initial velocity of 8 meters per second? Now, with all these questions, we want to consider the direction of the initial velocity as positive. So for any physical quantity heading downwards, we'll consider that as a positive measurement. So in this scenario, we're going to first of all try and work out what is the impact velocity. So as always, let's write down our variables first of all. So we know our initial velocity is downwards, a positive 8 meters per second. Our displacement is downwards, a positive 7 meters. Our acceleration is due to gravity, 10 meters per second towards the ground, which is also positive. And we want to know what our final velocity, v, equals. So let's now select an equation. Only one equation has a u, s, a, and v and is missing the t. Missing the t. Here's our equation. v squared equals u squared plus 2as. Let's write that down. Let's now substitute our values into the equation and solve for the unknown value for v. So on this point of time, we know that v squared equals 204. To find v, we simply take the square root of both sides. So a ball with an initial speed of 8 meters per second being thrown downwards at a height of 7 meters would strike the ground with an impact velocity of 14.3 meters per second. Finally, we want to calculate the time it would take an object being thrown at 8 meters per second to travel 7 meters to the ground. As before, we're considering the direction of the initial velocity to be positive. So downwards in this story is positive. So let's write down our variables. We know we have an initial velocity heading downwards of positive 8 meters per second, an acceleration due to gravity downwards with a positive 10 meters per second squared, and we have a displacement of 7 meters downwards as well, so it's positive, and we want to know the time. Only one equation has a u, a, s, and t. It's the one missing the v. The one missing the v is s equals ut plus a half at squared. Now, all we need to do for step 3 is substitute those values into the equation and solve for t. I've chosen this particular example just to demonstrate that not all the SUVAT equations are simple. So let's have a look at this. This equation has both a t and a t squared component. It is in fact a quadratic. Let's rearrange this into its normal quadratic format. In order to solve this problem, we'll need to treat this as a quadratic. Using the quadratic equation, with the coefficients for a being the 5, b being the 8, and c being the minus 7, we can substitute our values in to find the value for t. Negative b was the 8, plus or minus the square root of b squared, take away 4, times a is 5, times c is negative 7. All of that divided by 2 lots of a, which is 5. Now, at this point in the calculation, we have a value here which will end up being negative. You can't have a negative time, so this is the option we'll take. Let's simplify that even further. Okay, so what was a simple SUVAT equation ends up being quite a complex quadratic equation with the answer of 0.628 seconds, meaning an object being thrown down with an initial velocity of 8 meters per second, traveling a displacement of 7 meters, will require a time of 0.628 seconds to complete the journey. Simple SUVAT equations, but yet quite a complex quadratic equation to solve.
You've been watching a Juddy Productions video. If you've enjoyed and indeed learned something from this video, then please remember to like, share, comment, and subscribe. And as always, thanks for watching.